Thank you. And let me start by thanking the organizers for both the collaboration and the support in bringing women in quantum more to the forefront. And not only like placing us and giving us a platform, but also putting us in the keynote room and not giving, like, not having a competing sessions on the side. So I understand that for some this might sound a bit tedious to talk about women in quantum, but we as women, we would also prefer that this is not necessary, but unfortunately it is. So this talk will not be technical. I have a technical background. This talk will be about what my company does and who we are and where we come from and what I do and what I did and where we come from. Just as an introduction to the panel that we have here. So we're doing quantum-enabled technologies at BWI, and a bit to who I am. I have a chemistry background, so I specialize in quantum chemistry and computational chemistry, and for many, many years I worked in that area in different academic positions. So quantum chemistry, you describe chemical systems by quantum mechanics. Computational chemistry, you calculate chemical system on the computer. There's a lot of overlap, and I worked in a lot of quantum chemistry areas in computational chemistry, but there are also a lot of chemical systems that you do not calculate with quantum chemical methods that are also relevant if you want to talk about what we want to do with a quantum computer, and I worked in these as well. 2020, I joined Riverlane, a company who does software for quantum computers. There will actually be Steve, the CEO, on the panel later this day as well, talking about error correction. And I started as a chemist, but then in the end I had a small team, a research team on applications and algorithms, and we looked into that question, how can we actually get quantum benefit. And now I'm working at the BWI, or BWI as we say in Germany, as a technology lead for quantum computing, as a technology expert. So who is the BWI? The BWI is the IT system house of the German Bundeswehr, which is the German Federal Defense Forces. And you can say that basically we are a private company that has one big customer, the military, the Bundeswehr, but we really understand ourselves as the primary partner of the Bundeswehr. So we really see them not as a customer, but as a partner. And when you talk to my colleagues at BWI, I just recently joined, but I talked to a lot of colleagues at BWI, and really everyone feels the responsibility and takes it very serious, the job that we're doing, and that we're the partner of the Bundeswehr, because we are not only aware, but also we have a lot of respect for the people, humans who actually save their lives for us, and we are very committed to doing our best to provide them with the best support in all digital questions that we can. And it also says here, partner in peace, crisis, and war, and this is another thing that at the moment is very important, because if you think back 3 years, we were in a very different situation geopolitically, so I don't need to tell you that, everyone knows that. And that also means that a lot of efforts at the Bundeswehr and the BWI are increased now, so we really need to increase what we're doing. So just a few facts. So we are quite big. We are scattered around Germany, many different locations, and we have about 7,000 staff members at the moment, numbers rising. What do we actually do? We do all of the IT questions that the Bundeswehr can have. So that starts with simple operations. So everything from rollout of mobile phones and laptops and computers up to then customer solutions, bespoke solutions that might be necessary for the Bundeswehr that we maybe do not find in other areas of business, and also the two right areas that are more important for quantum computing. We do consulting. We are linked very closely with our partners and our clients. And where quantum computing is located is in the innovation sector. We have to think now long term about what will happen in the future. We cannot wait until the technology is ready and then be surprised by what's going on, and actually everyone is using the technology and we are lacking behind. So this is the team, the quantum-enabled technologies team. On the left, you see 4 people who are the technical people. Everyone is a technology lead for different areas. We have 2 people for quantum communication, 1 in quantum key distribution, 1 in post-quantum cryptography, then 1 in sensing, and I do quantum computing. We have 2 non-technical people who are the leadership team. And I normally don't point this out because I feel like it should be normal, but from the 4 technical people, 3 are women. Okay. So this is a bit about what we do, and the most important part at the moment for us is quantum communication. The big topic of post-quantum cryptography, we are very active in that area. We really try to be at the forefront there and put a lot of effort in that, because safe communication in defense questions is super, super important. It's one of our core businesses. And we are aware that we need to act now, because whenever that quantum computer comes, we want to be ready and we want to be prepared. So we have identified this as a high priority strategic risk, and we are very active in that area, and my colleague works on that. And another colleague works on quantum key distribution, where also we have some projects running, and look into how to actually ensure that we can communicate safely in the future. Our quantum sensing efforts, again, another topic that is very important in defense questions is intelligence and information, the gathering of all kinds of information, so everything that you can get through a sensor. And quantum sensors promise to give us much more possibilities of what we can actually get in information data. And there we are very closely looking into what happens in the field, so evaluate and adapt the quantum sensors, do a few case studies and scenarios and trials with the military, with military relevance. And then the last bit that we do in quantum computing, which is my area, we overall at the BWI, we do not do any research. Okay, so it's not in our contract to do research, because we also are funded from taxpayer money, and so the tasks are very clearly defined, and the task is very clearly defined as not doing research. But what we do is monitor and evaluate the technology progress all the time, and keep on top of what's happening in the ecosystem, keeping the long-term perspective in view. When we do projects, we do that for the other areas, then the technology needs to be advanced to a certain level, and we do not see that at the moment so much with quantum computing. We cannot learn, we feel, so much by doing, like, setting up the next optimization problem that deals with the next topic, and then do a small calculation on 10 qubits on a toy system. So we don't feel we can learn from that. So we really keep the long-term perspective, and for us it's very important to communicate honestly but optimistically. So we are aware that there are lots of problems in quantum computing, for example in algorithms. So I come from an algorithmic group in my last job. We know how difficult it is, for example, when we speak about quadratic speedups in algorithms and so on. So we are very honest about that, but we are also optimistic. We still look into these technologies, into these algorithms, because we need to keep an overview over all areas. And but the good thing is we don't really sell anything, so we can also be very honest. And if we don't want to talk about VQE or HHL and so on, then we don't have to. So we are really there to be the experts for the BWI in our different areas. We give recommendations, guidance, and we place the topics in the company, so raise awareness and facilitate. And that's already it. Thank you very much.